Welcome to Section 8.3, Methods of Proving Triangles Similar. Our objective is to use several methods to prove triangles similar. For homework, we're going to be working on page 341 to 343, numbers 1, 3, 5, 8, 9, 12, and 15. Now I know what you're thinking. Proofs again. I promise you, this is one semi-isolated section of proofs that we're going to do, but it's really going to make sure that we have a true understanding of what similarity is. So we have three ways of proving triangles are similar. We have angle-angle, side-side-side, and side-angle-side. So let's talk about each one. In order to have angle-angle similarity, we need to have two triangles, and in those two triangles, we need to have two sets of congruent angles in order to prove that triangles are similar by angle-angle. To have side-side-side, again we need to have two triangles, and from those two triangles we're going to label the vertices A, B, and C, D, E, and F. What we have to have happen is that all three sides need to be proportional. For instance, AB over ED needs to be equal to BC over EF, which needs to be equal to AC over DF. And last but not least, for side-angle-side similarity, again we have to have two triangles. We'll call the vertices A, B, and C, D, E, and F. We need to have two sets of proportional sides, such as AB over DE and BC over EF. And with those two sets of sides, the included angle must also be congruent. So for our first example, we know the sides of one triangle are 12, 8, and 14. The sides of another triangle are 18, 21, and 12. And we want to show that the triangles are similar. Knowing three side lengths, the only way to prove similarity here is going to be side-side-side. Now, like in the last section, what I want to do is I want to try and match up my smallest side with my smallest side to form a ratio, 8/12. I want to take my medium side and match it up with my medium side to get 12/18. And I want to match up my biggest side with my biggest side to get 14/21. And let's reduce all of them. 8/12 are both divisible by 4, gives me 2/3. 12/18, they're both divisible by 6, gives me 2/3. And 14/21, both divisible by 7, gives me 2/3. Since all three sides reduce to give me the same ratio, I know that they're going to be similar by side-side-side similarity. Next, we have a proof. So given ABCD is a parallelogram, we want to try and prove that triangle BFE is similar to triangle CFD. Well, here we go. We got our statements and our reasons. I know how much you've missed these. We got ABCD is a parallelogram that's given to us. Now, here's the triangles I'm trying to prove similar. We have BFE and we have CFD. And what do you notice that those two triangles have? Hopefully you said vertical angles. So let's go ahead. Angle CFD is congruent to angle BFE because the vertical angles are congruent. And I'm going to mark it in. Next, if I have a parallelogram, I know opposite sides are parallel. So I'm going to say DC is parallel to AB. Opposite sides of a parallelogram are parallel. And with that, I can look for my alternate interior angles. Alternate interior angles, again, are going to form those Z's. So for my alternate interior angles, I have angle DCF is going to be congruent to angle FBE. If lines are parallel, then alternate interior angles are congruent. Now, once I put those markings in, I see that I have two sets of congruent angles. Therefore, triangle BFE is similar to triangle CFD by angle-angle similarity. For our last example, we're given that KH is the altitude to hypotenuse GJ of right triangle GHJ. We're trying to prove that triangle KHJ is similar to triangle HGJ. So here we go. We got our statements and our reasons. That KH is the altitude to GJ, and we also have a right triangle GHJ. Those are going to be our givens. You wouldn't be wrong just to write that as one given. I want to separate that just to make sure that we're okay. Now, I want you to press pause and see what you can do in order to prove similarity. Alright, here we go. If we know that we have a right triangle, where my right angle is going to be is across from that hypotenuse. If my hypotenuse is going to be GJ, that means that angle JHG is a right angle. The reason? Definition of a right triangle. I'm going to go ahead and draw that in. Next, if I have an altitude, I know I'm going to have right angles at their intersection. Here's my intersection. Now, you can name both right angles if you would like, or since we're trying to prove triangle KHJ, that's this triangle over here, the only right angle I truly need is going to be angle JKH, is a right angle. Definition of an altitude. Next thing I want to do is state all right angles are congruent. Angle JHG is congruent to angle JKH. All right angles congruent. Now, next, let's look at those triangles I'm trying to prove congruent. My one triangle, triangle KHJ, is this triangle right here. My other triangle, triangle HGJ, is this triangle right here. What do you notice they have in common? Hopefully you set an angle. We have a reflexive angle between both triangles. It's at angle J. Let's say angle KJH, which is part of the smaller triangle, is congruent to angle GJH by reflexive. I'm going to mark that in. Now I have two sets of congruent angles, so I can say triangle KHJ is similar to triangle HGJ by angle-angle similarity. So here's the answers to our homework. Again, we kind of had a smattering of different problems, 1, 3, 5, 8, 9, 12, and 15. As you can see, they're pretty much all proofs. If you have any questions, please make sure you ask them tomorrow in class. Remember, we have one more day, so anything that we need to go through from sections 8.1 through 8.3, we'll make sure that we get this answered by Friday. And as always, have a good one.